All right, welcome back, everybody. This is the second to last class. So we'll do a little bit of talking just sort of about our feelings over the last 5 weeks of me lecturing and talking at you. But I think first, actually, what we'll probably do is we'll go through one other little notice or idea within within the Web UI notebook on Superresolution. I'll just talk about some of the differences between the tools that are available in there. So we'll probably do that for like an hour-ish, and then we'll take a break, and then we'll just catch up again and sort of talk through everything together. I was talking to my ITP class earlier today, and they were all like very excited to hear they didn't have a final assignment due for them. This is the end of their semester and they've got millions of other classes, but I do, so again, knowing that we only have 2 weeks left, next week being the last week, not really expecting people to have full-blown projects coming out of this. But at the same time, what I want to make sure that does happen is that you're given enough of the future resources to be able to sort of continue the project yourself or know where to take things to the next step if a new model comes out, that sort of thing. So while there isn't really like a lot of time for the final big project for everyone, I want to make sure that people have the resources and are able to get started on a project, whether it's training or videos or other things that might be kind of big and hefty. I want to make sure that you're feeling comfortable and ready to set up. And with that in mind, it's also like, please continue to reach out to me. So even after class is over, if you have ideas for projects and you're a little stuck, like I'm happy to meet with you for 10 or 15 minutes over Zoom and just sort of give you some direction on where we can go with it. So even though class will be over, please never feel like you can't ever reach out to me again. So I'm more than happy to set up time and just sort of, catch up and figure out what we can do to make sure that you're getting started on our project you want to start. Sound good? Cool. So why don't we start by just, we'll go through the notebook. There actually were even more updates. As I mentioned, there's just so many updates with this particular notebook every week. And I know I have a couple people in my ITP class said they ran into issues. So we'll go through it today and just make sure there are no lingering issues with people. And then we'll mostly just look at the Superresolution tools within the notebook to talk through how we can use them. So let's get started. So let me just drop the link in here for everybody. So again, normally I say, hey, it's cool if, the first thing you should do when you enter a notebook is make a copy of it and then start taking notes for yourself. With this notebook, that is absolutely not the case. You do want to sort of always use the latest one. So that GitHub URL will always give you the latest. So we'll go ahead and just get started. We'll connect the drive. So you'll notice a couple different things. If you're familiar with this notebook, you'll notice that all of a sudden the requirements are higher up than the model download is. It used to be requirements was after this. The other thing you'll notice that inside of the install on Mac 11.11 repo, there's no longer a checkbox for update repo. I think the developer got sick of telling people that they had to update the repo. So he just actually hard coded in an update repo variable in here. So now every time you run this, it's going to update your repo. So, I mean, that's probably good because it's going to give you the latest and greatest, but it might also introduce some issues where if you have a thing that's working the way you expect it to, it might not in the future. So just be aware of that. I think in general, I would say it's probably good that the update repo thing is just turned on now, but it can lead to some potential issues in the future. So just be aware of that. You can always go back into and find an old notebook. So if there's a particular feature that may be changed, you can usually on GitHub go through this, it's on github.com/thelastben/fast-stable-diffusion. You can go through there and actually find the checkpoints from previous versions. If you want it, most of the time you won't need it, but just in case it is available there. The other thing that I noticed this week, and I don't really know if this was always acted this way or if I just never noticed it, but if you had run last week, the path to the CKPT of the model that we fine-tuned trained, it always, I think it default to the last model you tried to load. So earlier this week, I was trying to just sort of do some testing. And of course, because that model is so large, you need the high RAM setting turned on. and I found that this kept crashing and I couldn't figure out why it is because I was trying to load that old model. So what I might recommend we do for this last step where we load in the model is actually grab the model directly. So one of the easy ways to get it is to just go into our SD folder and then go into Stable Diffusion Web UI and then go into models and go into Stable Diffusion. And then in there is the model.ckpt. So if you copy that path and you paste this in, and drop this in the chat for everybody too, it will then load that one. And just remember that model.ckpt is SD 1.5. So we're just going to stick at 1.5 for the rest of class because I think 2 introduces some other issues with loading RAM and stuff. So we're going to just ignore that for now. So we will just use 1.5. So this path should be the same for everybody, and it will give us the SD 1.5. If you don't see model.ckpt, then you might have to go back into Hugging Face, grab your token, input your token here, and then do re-download the original model. Seems like they might have fixed one of the, I feel like there was a bug where like some of the CKPT files kept disappearing. Seems like that's been fixed and you should just have it this way now. So when you hit play here, you should get using the trained model. And then we just go ahead and hit start Stable Diffusion. So while this runs, I'll talk a little bit about what we're going to do and look at super resolution today. So for most of the class, you've probably seen that I just use the 512 by 512 size, right? And we'll look at the reason why I do that to start with when we start up this notebook. But obviously 512 by 512 is pretty small, especially if you're going to try to print something, right? You need like 300 DPI. That's like 1.5 inches tall. That's like not a very big size. So obviously, if we want to print something or have just something a little bit higher resolution, we want to figure out how to do that. I know many of you have been in my class before and we looked at super resolution tools. We'll look at there are some of the built-in super resolution tools in this notebook. But there's also another technique that they're kind of calling SD upres, which we'll look at first, which actually just kind of uses image-to-image translation, but it kind of uses it to do upresing in an interesting way. So there's actually a bunch of different ways to do super resolution within this notebook. And I think that's pretty interesting. And you'll find sort of the pros and cons of each of them as you go through it. So we can kind of take a look at that. For those of you who have not looked at super resolution with me before, just a quick discussion on what super resolution is. So, obviously we want to make these images bigger. We could bring them into Photoshop and we could just resize them in Photoshop, right? So we could take a 512 by 512 image, bring it into Photoshop and resize it to 2048 by 2048. Excluding one setting within Photoshop, what that's going to do is actually just going to take your pixels, and it's an algorithm that tries to figure out what the bigger pixel should be, right? So you're basically turning, in that case, you're turning 1 pixel into like 16 pixels because it's like 1 4x or something. So you're just basically the computer just tries to figure out a smart way to interpolate those pixels into the right size. Usually what that leaves you with is actually a blurry image, or worse, a very pixely looking image. And that's just because, again, these are algorithms. They're making their best guess based on the pixels they see and are trying to make the image larger. But in most cases, when you would then try to print that or look at that image, it's going to be blurry. In machine learning, because machines are basically designed where if you have a data set that is high res and you convert it to an image that data set is low res, the machine learning model can learn those differences, right? So a super resolution model is trained on a set of images that are high res and a set of images that are low res. And you start with the high res images, you just downscale them to low res, and then the model can actually learn, similar to how diffusion works, right? It can learn to add noise and then take away noise. Similarly with a super resolution model, it's a model that learns the differences low res versus high res, and then it can do the reverse. Adam, I'm checking out your error here. Yeah, so this is the error that so if you look in the chat, this is one of those errors that is just unfixable. So what I recommend you do is take your SD folder and in Drive, just duplicate it. So just do like SD old, just rename it. and then you'll come back here and rerun it, and it's just going to rebuild your SD folder from scratch. The reason I recommend just duplicating this is that you don't want to lose the images you've made. What I'd probably recommend doing is like either downloading those images and then deleting that old folder, or going through and figure out what images you want to keep. One of the downsides of this technique of just duplicating this folder and renaming it is that your model files are still in here, and these model files are like a couple gigabytes each, right? So you'll make sure you delete those eventually. But if you're just looking for a quick hack to make sure that this notebook's working, that's kind of the easiest way to do it. Cool. Yeah, so super resolution models. We end up having these models that can then actually make images larger. But what's cool about them is, unlike, say, the Photoshop techniques or other basic computer vision techniques, is where those computer vision techniques tend to make images sort of blurry because it's just interpolating the pixel values. These models actually include or add texture to the image as you upres it. So the plus side of that is it stays crisp, it stays sharp. The downside is that it tends to introduce what I would describe as like the neural look, which means little like wormy wiggles and stuff. We'll see them in these notebooks when we look through it. So what you find is that there's probably like 15 super resolution networks these days, and all of them have little pros and cons. And the downside is that the best way to test what works best for your image is probably just to run it across all those networks and to see what you get, and for you to sort of pick what the best super resolution network is. But in general, I would say any super resolution network is going to be better than anything you get in Photoshop. So I'm just going to go ahead and open this, and I'm just going to sort of show you what happens. So the first thing I want to do is show you what happens when you try something at 512 versus 1024 and what these stable diffusion networks sort of do. So I was doing this earlier. I don't normally work in portraiture, so I don't actually know a good prompt to generate a portrait picture. So I'm actually just going to Google this, which is, let's see, stable diffusion portrait prompt. And I just picked this example, and I'm sorry, all the photos that they're going to show in here are like the absolutely horniest photos of people you can imagine. It's really embarrassing, but there's one or two good prompts in here, so I'm just going to use one of them. So I'm just going to scroll past the horny stuff and get to like a good prompt. Where did it go? I think it was this one that I was using. So maybe you can look at this post and see if there's anything interesting in there, but I kind of find most of the posts to be very embarrassing. It's like, very beautiful celebrity, and then it's like, I don't know, big boobs or something, which is just embarrassing. So we'll pop this in here. I also found that I need to say a portrait of. So I'll drop this in the chat if anyone wants to use it. And then I'm just going to add a couple negative prompts. So ugly, confusing, abstract text. So let's just make sure we don't get any text or watermarks in there. So we'll use sampling steps of 40. And we're going to keep our height and width to be 512 for now. And let's just set a fixed seed. So I want to set a fixed seed because what I want to sort of show is that when I change the size, even if I keep the same seed, I get kind of a messy image. So I'll do 101. I think I did 100 in my earlier class. So let's change it up a little bit. So I'm just going to go ahead and generate this and see what I get. Okay. Actually didn't give me what I wanted. Let me go back to seed 100 and see if I can get my face back. I wanted I want that sort of classic like portrait look of someone with their face sort of well defined within the frame. There we go, that's better. Okay. So this is a portrait, pretty well done portrait of someone in this shape. So your default assumption might be, well, like, hey, let me try to make this 1024 by 1024. And what you would do is you'll just crank up the size to 1024 by 1024, and you'll hit generate. And spoiler alert, you're not going to get a portrait at 1024 by 1024. This also takes a little bit longer because you are asking it for more pixels. Okay. So at 1024, I actually get two faces, and I get two faces in these slightly shaped, weird shapes. And of course, the bodies are a little more amorphous. So what happened here? So remember that by default, Stable Diffusion generates images at 512 by 512. And in SD2, there's a new version that's 768. But by default, there is no model in Stable Diffusion that generates 1024 by 1024. So what ends up happening here is when you ask for an image larger than that size, it kind of does a thing where it almost sort of collages a bunch of 512 by 512 models together. So in general, if you ask for something like a portrait at 1024 by 1024, you will usually get 2 to 3 or 4 people, because it's not really, it's using a 512 by 512 patch and then kind of upsampling it, or like, you know, finding a way to make it all work together. So this is not the way that if you want that simple, they want that nice classic portrait look. If you want it at 1024, this is not the way to do it. The way to do it is actually, you'll see down here, right below this size is this button that says high res fix. And if you click that, you'll see that a new set of options here opens up. And we've got first pass width, first pass height, and denoising strength. And obviously from the image to image world, we kind of know what denoising strength might be, right? So for this, what we're going to do is we're going to turn the first pass width up to 512 and the first pass height up to 512. In general, I would never turn these higher than 512 because, again, Stable Diffusion default starts at those sizes. So what this is going to do is, this is because we're seeing our denoising strength, and kind of guess this is an image to image technique. So what this is actually going to do is going to generate our image at 512 by 512. Then it's going to upsample it, and then it's going to run an image to image translation on top of it. So we know from image to image translation, the way we can use this is the higher this value is, the more our image is going to differ from our low res image, right? Because when we load it up at a higher res, if we set this really high, we're going to add a lot of noise in that image before we change it. So my recommendation for you is, if you like that 512 by 512 size, you want to keep denoising strength kind of low. So like 0.3. So let's run this again and see what happens to our image. So remember, this was 1024 before, and now we're going to run it again and get a new 1024 by 1024 image. It seems it's running faster, but I don't know if it actually is. Like, I noticed the ETA was like 18 seconds and just paused there at 18 seconds. I don't know how they're running this ETA system, but it's a little funky. Yeah, my initial hope was like, oh, it's gonna run faster, and now it's kind of like lagging here a little bit. There we go. This looks a lot like our previous image. And that's because we started with a 512 by 512, and because we locked our seed, we should get that image again, because we didn't change anything between text prompts, settings, anything else except this step here. So it generated that exact same image that we already have at 512 by 512. Then it up-resed it. And I don't know if it uses super resolution or if it just uses like a normal, like, linear up-res. I actually kind of think it probably just does linear up-res because it's faster. Then it does the image to image technique. And what that sort of allows the model to then do is you're going to actually you're basically guiding it to look like this image. And that's going to make it a lot cleaner and make it look a lot more similar to the low res version. Now, one note is if we were to actually open up the low res image and compare it to this, we would still see some subtle changes. And that's because of this denoising strength, right? So maybe the hair changes a little bit. Maybe some of the other textures change a little bit. We'll still see some changes, but overall the changes will be a lot more minimal. Now I could crank this up. Like if I crank this up to 0.9 and run it again, I'll probably see more of a portrait, unlike that sort of like multiple bodies, but I will definitely see a bigger change between this person and the low res version to the high res version. Yeah. And in fact, I probably turned this up so high that I actually kind of got this like weird distortion. Because there's so much noise in this, it's almost going back to that version where it's going to end up generating multiple collaged faces into this. So I think the key here is if you want to use the SD upscaler or the SD upres trick, you really don't want the denoising strength that high. And maybe you do if you really want to make this sort of distorted shapes, right? Like if you want a face that looks like a portrait face, but then you want to add like some weird distortions into it, you could probably set this pretty high. It's still going to maintain a lot of that underlying shape, but you'll get some of these weird like double and triple noses or the eyes in weird places. But if you really just want that classic sort of upsampled look, you could probably just use something like 0.25, 0.3, 0.2. Too low, and you're probably just going to get some of that blurriness that comes from that linear upsampling still. So you have to crank it up a little bit more than that. But finding a good like sort of Goldilocks region for this is probably gonna be like 0.2 to 0.4. So that's what they're describing as SD upscale. Any questions about this technique? One thing I also want to mention that's kind of cool about this is you can also use this to get non-square crops. So what we could do here is we could set this to be 512 by 512, which just remember is always going to be sort of the native resolution of these models. But then you could turn your width down. Let's do like 768. And yeah, I'll keep my denoising strength there. If I run this, what'll happen is, I think what's happening here is it's going to give me that 1024 by 1024 upscale, and then it's going to crop down. So this is also a good technique. Like let's say you actually do get a good body portrait or a body shape or body aesthetic at 512 by 512. And let's say you want to up-res it, but you don't want actually a square image. Then the way to do that would be to keep it at 512 by 512 on the baseline for the first pass, and then change the height and width. I think the height and width still does some cropping. It's not clear to me whether it does that as it scales up or whether it does that post-processing. I need to look into that a little bit more. But either way, this will give you a non-square crop, which will still be a portrait, which is kind of nice.
Derek, what do artists do that want to get higher than 2048 for, like, let's say, like exhibition ready work?
Yeah, that's the next technique we'll look at,
Okay.
which will just be using super resolution natively. Yeah, these models, especially if you're on a 16 gigabyte card, by default just can't really generate big images. Like Stable Diffusion is a pretty large network, and trying to generate really large images, it's just going to be like, I can't do this. Like it's gonna run out of RAM. The next technique we'll look at, which is super resolution. The cool thing about super resolution is because it's what we call deterministic, meaning it's always the same output if you give it the same input, is you can actually do tiling then. So you can tile an image. It'll do it all behind the scenes for you. You don't have to do it manually, but you basically tile an image and then super resolution just those tiles. And then when you paste it back together, it actually is, it all seamlessly matches together. And you've now up-resed it really, 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 really large. So that's how you would do it. Yeah, so you'll see here, we did get a crop. Again, I'm not entirely sure if it crops it post generation or if it does it as it upreses and then it runs the image to image again. I need to kind of experiment with that a little bit more, but you can begin to get good square crops. So again, the high res fix is really helpful, especially if you want something that's natively a little bit nicer texture. One of the things we'll notice is, so there's two things to think about this. One is that this will change your low res image, right? So if you have a low res image you really, really like, when you use this technique, you will get a little bit of difference in your output because of that image to image translation. The upside is, unlike say super resolution, which we'll look at in a second, this doesn't add in sort of that neural look. That sort of like, if you zoom in really closely, you get like some kind of like little grainy textures. So you kind of have to balance out the two with each other. So what I would probably say is it might be good to use this technique to get to 1024, to get to 1560 or whatever it is, but that you might want to still use super resolution as the final step. The thing about printing this stuff, right, is you print it at 300 DPI. So when you actually scale it back down, you do lose a lot of that little texture and it doesn't really affect the image too much. But if you're going from something like 128 by 128 and using super resolution to blow up, it will show a lot more of that texture. So I think the good thing is to kind of natively try to get to like a decent size, and then from there to use super resolution to make it a little bit larger. All right, so let's take a look at how to do super resolution. So the first thing I want to do is I want to actually just generate my image. So I'm going to go back to my 512 by 512 here. I'm going to turn off the high res fix. And I just want to generate a good solid SD image using this. So we'll go ahead and hit generate. So I should just see like this portrait again in a square format. Yep. Oh yeah, it must just crop in. That's definitely what it does. Okay. So then what we want to do is we want to hit send to extras. So that's going to send this image to our extras tab. So go ahead and click send to extras. And there's our image. So you'll notice here we've got single image, we've got batch process, and we got batch from directory. So the nice thing about this tool is if, let's say you generate a bunch of images, you spend an hour just generating images, and you're like, well, I don't know which one I want to pick, but I do want to upres all of them. You could go back here and do batch from directory and just point it at your directory folder and have it upres all of them. And that would be kind of a nice, like little, it's faster than going through one by one with all of them. You could also, I believe, drop in a bunch of images if you wanted to. So it's kind of nice. You could batch process some of this stuff. So within our single image tab, we've got here scale by and scale to. So scale by is like a multiplying factor. So this would be 4x. So if my image is 512 by 512, it's going to be 2048 by 2048. You can also set a scale to value, which would be a pixel based value. So you could do something like, 1024 by 1024, or you could set a cropping value on this as well. I think, again, it would scale it up and then do the crop after. There's different techniques for people that use these scale by values. One option is to just jump directly to 4x. Another technique that I tend to use more often is to do 2x and then 2x again. I personally tend to find, in my experience, that running the same scalar multiple times over the image gives you slightly better texture or slightly better sharpness, but at the cost of having to do it multiple times and having to remember the file name and that sort of thing. So it's hit or miss. The other thing to note is that most of the models they use by default in this tool are 4x models. If you were to go and look up, I think ESRGAN or SWIN IR, which are these machine learning models, you'll often find they have a 2x and a 4x version. For whatever reason, they only included the 4x version here. So that might be why you might want to leave it at 4x, because you're just going to get the native rescaling values from these models. So we can leave it at 4x for now. I think it's fine. So we're going to set the resize factor to 4x. So that's just going to be 2048 is going to be our output size. Next, we have a bunch of different options below here. So the first is Upscaler 1 and the second is Upscaler 2. So I tried to do some research on this week and I couldn't actually find an answer here. I think these upscalers are just doing like a frame blend. So if you set one of these upscalers to be SWIN IR and you set the other upscaler to be ESR-GAN 4X, I think all it's going to do is generate two different images and then sort of like do a blend of the two over top of each other. Because I don't know any way you could actually like blend the machine learning models. Maybe you can, I don't know. I Googled a lot about this particular experience and everyone was like, it's easy, you just use it. And I was like, that does not explain how any of this actually works. So I've yet to find documentation on how this works, but I assume that what it is it's just like almost like a Photoshop layer blend. And you'll see that here with Upscaler 2 visibility is set to 1. So I think what that means is if I set this to 1, it's either going to be just Upscaler 2 or it's going to be like some strength indicator of this upscaler being stronger than the other. So I think what I would probably do, and I haven't really tested this too much beyond the past couple of days, is I would just set this to 0. And then I would just always remember that whatever I'm doing with my upscaler is going to happen in Upscaler 1. So we'll start there. We'll come back to these other features in just a second. So within Upscaler 1, you'll see there are a number of options. There's none, which I don't even know why that's here because there's no reason to do that, but it exists. There's Lanczos and Nearest. These two are actually not machine learning models. These are what this is what Photoshop does. So Lanczos is the most common linear upscaler, meaning this will just take all your pixels and run an algorithm and guess how big to make it. I think it's a little confusing that they include it here. I guess there's a reason why you would do it, which is maybe you want to do these image-to-image tools. But I would rather see people sort of categorize these two as not machine learning models, and therefore, like, you might want to skip these. So I would not recommend ever clicking either of these because they just make your images blurry, or in the case of Nearest Neighbor, which is actually just going to duplicate your pixels, this will make it very pixelated. Again, not something I would recommend using. Maybe there's a reason to within this tool, but I would just skip these. The rest of these are machine learning models. And the thing I should also say is they'll be a little bit slower, right? This first two will actually be fairly quick because they're just like an algorithm that looks at pixels. These other ones will be run through a machine learning network, then will take a little bit of time to get set up. I actually have not heard of a couple of these. The ones I've used the most are SWIN IR and ESR-GAN, and our ESR-GAN. I've sort of used these three the most. I should probably go and look up what these other ones are. But in general, I've had good results with these three. Now it's kind of always a little different depending on the image you use. So this is a case where you might want to just run it a couple times, or each take an image, run it on all three of these and sort of pick your favorite. There's like a whole YouTube channel devoted to comparing all these upscalers because there's so many now. There's like 50 different upscalers. I wonder if let me see if I can find it really quickly. Let me see, Superresolution comparison. Oh, I don't want AMD, I just want Superresolution. Yeah, so see that like there are people who's like, this is a year ago, so this one's kind of old, but there are like, I know I've definitely come across some of these. I'll have to look, I'll try to find one again. But there's just so many of these upscaler comparisons that, you know, people will go through and provide like something like 15 different ways in which they're like scoring these systems, and they try to pick the best. And it just ends up being like, every one of them is good at some things and bad at other things. And it's just like not worth kind of like trying to pick your favorite. It's just like pick one, and they're generally pretty good. And you might find little differences between them. So I would say to start with, just play with them and sort of see what works best for you. A lot of them are like how they handle blur is slightly differently, or how they handle sharp straight lines versus not. Like, it's really detailed. And I would probably say like the best thing to do is just start to look at them, and maybe you'll get a feel for them over time. So let's just pick SWIN IR. I've used this one a lot. I find it works pretty well. So at this point, we can just pick that, and then we'll go ahead and hit generate. The other funny thing is that for some reason in this tool, there is no ETA. It just sort of takes as long as it takes. I kind of feel like this was sort of thrown into this notebook as like a, hey, we know people want super resolution, so let's make it available. But it's not as, I don't know, I'm not even saying like the text image GUI is that great, but this one's clearly not great. It's kind of just like a bunch of kitchen sink items that you kind of have to guess and figure out how they work. And there's no documentation about any of them. Right, so this is now 2048 by 2048. Now, if I open this, I'm just going to copy this into Photoshop. I don't know why you just can't open that tab. So if we look at this image is 2048 by 2048. And when we zoom in really close, this is sort of what I mean about the neural look, is you get these sort of areas where there's sort of like this little like wiggly lines. That's a really common thing to see in sort of these upscalers, like especially in little details, because remember, these models are trying to convert like 3 pixels into a big image, right? So it's a big challenge for these tools. And you'll often see that there's some sort of issue here with how these work. I don't know if this hard line is actually in the image or if it's in just a Photoshop error. You'll also see like another key place to look is in eyelashes. You'll see different results here in different eyelashes. Like if I go in, and let me just run this with, instead of SwinIR, let me run it with ESRGAN. I bet we'll get very different looking images in the eyelashes. And if you look up close, you can sort of see this face is kind of a little bit weird. Those eyes, the irises are not perfectly circular, right? That's just how these models tend to be. You'll notice the nose is doing some weird stuff. But overall, I mean, the skin is like almost creepily smooth. It's like porcelain smooth. But overall, like this is now a 2048 by 2048 image that is pretty good looking. Like I wouldn't necessarily worry about printing. I wouldn't be worried about printing this image. It's going to look pretty good, you know. And when you actually compress a lot of this down and print it on like a paper with a little bit of grain, you're not really going to notice this as much. And that's kind of what's cool about these models. They do a good job of really adding enough texture that doesn't look blurry. But you know, if you look close enough, you can find little issues with them. So I want to open up this one because I feel like this one's going to look a little different. The image. Oh yeah, wow, look at this one. So this one added way more grain. And you'll see in the eyeball, there's a little bit of this like neurally bits. You can kind of see the skin wrinkle into the eye. ESRGAN was like one of the first big super res models that people really liked. SwinIR came a couple years after it. So I think you can definitely see that it's probably a better model. Maybe if your image already has some grain in it, you might actually like this look because it adds a little more grain into it. This might also actually print better. If you've done a lot of printing before, you know that noise actually kind of helps images a little bit in printing. So you kind of have to experiment with this stuff and sort of see what happens. Let's try the last one here. Let's try, what is it? ESRGAN. So I think this is what's called real ESRGAN, which is a new version of ESRGAN, because of course they can't just change the name or call it ESRGAN 2. They have to give it a different name. So this one is I've sort of heard between all 3 of these, people mostly debate about real ESRGAN and SwinIR over like which one's the best. I don't know if these other ones here are brand new and I just haven't heard anyone talk about them yet, or if they're other models I'm just not aware of. And lastly, I should mention there are a lot of super res models for anime images. So there's obviously one buried in here for anime, but there's like 50 other ones out there for anime as well, because lots of anime people like using these tools. You can probably imagine that you don't want to upres anime in the same way you upres a photo, because upresing a photo, you want to introduce textures. For anime, you don't really want to introduce textures in most cases, unless it's like a 3D anime. Right? If it's like flat image, flat illustrations, you don't actually want to introduce texture into that. So they've built a lot of custom fine-tuned models just for anime to keep those flat shapes. Because if you imagine like a pen stroke outline upresed, if it stops looking like a pen stroke and starts looking like it's almost like a photo or like something that's sort of bleeding into the image, it's not going to look good. So there's a lot of these custom models. So if you are doing even more illustration work or that sort of thing, you might want to pick that. Let's copy this one over and let's paste this in. So this is real ESRGAN. I didn't spell that right, but that's right. And this is SWIN IR. So if I zoom in, you'll see there are some subtle differences between these two. I think I still prefer SWIN IR a little bit more. That tends to be the one I go for. Although I guess maybe you would say like you don't really want wrinkles in this sort of like part of the eye. So I don't know, maybe this one is better. This one's certainly smoother. But I don't know if smooth is always good because look at the eyebrows. With SWIN IR, you get to keep a little bit of that hair texture, which looks right, compared to real ESRGAN, where it's a little bit more of a blurry smudge. Again, this is when you get into the really detailed work about these images to try to figure out like, oh, which one of these is best. You'll likely find that for different images, different models are better. So important to remember, with super res models, you are not doing any image to image translation. So it's very likely the changes you're going to see on the image are very subtle, like on the texture level, right? Like we just saw. Whereas the SD upscale, the method we used before, will actually alter your image. And it will alter your image depending on how much your denoising scale is set to. So that's the key sort of difference between these two. I would probably say, if it were me, I would still do SD upscale to get to a 1024-ish level and then run this on the image. Because at that point, you're really going to have just super fine details you're going to need to look at. And again, printing this is probably going to eliminate a lot of that sort of neural look because it's already a decent resolution. One other thing I want to show you is in this tab, at the bottom here, you also see 3 settings. So GFP-GAN visibility, code former visibility, and code former weight. These are actually facial upscalers or facial reconstruction, facial restoration models. So these are models that are particularly trained on actually trying to fix some of the minor details you might see in faces. So stable diffusion, obviously, as we saw, like it will produce like, you know, uneven circles for people's irises, maybe little weird shapes in people's noses, especially if you have a lot of images or like a lot of faces in a picture. The smaller scale, the faces, the more little like weird eccentricities, let's call them, you're going to see in those faces, right? So if I were to say, I want a family portrait of, you know, 10 people, it's very likely that the 10 people in that image, all those faces are going to be a little distorted. And that's just because of the compression that's built into these models. They don't really know how to draw perfect faces at really small scales because they're mostly trained to do lots of other things at small scales. So this is where you might want to turn on these tools. So GFP-GAN and CodeFormer are 2 different facial reconstruction or restoration images. I have heard from most people, again, it's sort of outside of stuff that I generally work in, I have heard that most people use CodeFormer over GFP-GAN now. So you can crank up your CodeFormer visibility, and then I guess there's a weight as well. Interesting, I read this completely backwards the other day. So 0 is the maximum effect, 1 is the minimum effect. That is very confusing, but apparently that's what the setting is. So if you want lots of face restoration, you set it to 0. If you want little, you set it to 1. Again, outside of my wheelhouse, I have generally found these to be better on small updates to faces or small faces in an image and not that helpful at stuff at this scale. So if we could run this and see, like I was trying to figure out if it would fix that iris issue. I never got to fix that iris issue. That iris was always a little off in this particular render. This probably also adds a little bit of render time. I think if I remember, so I think I mentioned this last week, but I highly, highly recommend you check out this wiki page, with all the features. let's just go face restoration. This will take a minute to load because there's a lot of images in here. But you can sort of see, whoops, lost all those face. You can sort of see, man, all the loading is really killing me here. As well as images load in. You can see that I think the code former adds a little bit of softness to the image. And again, this is where we're actually changing pixels, right? So it's not just like, I don't know, like a Photoshop filter where we're sort of, maybe sharpening an image a little bit. It's actually going in and actually changing the details of that image. You can see like GFP-GAN seems like it's got a little bit of harder highlight on the cheekbone, maybe a little bit rosier cheeks. This one seems a little bit smoother, a little bit softer. So you actually see that each of these has different settings or has different effects on your image. Again, it's kind of all depending on the look you want. So I would argue maybe you want this hard highlight look and you want to actually use GFP-GAN more. Here's another case where you just might be testing with the models to sort of see which ones work and which ones don't. So that is super resolution within these tools. Many of you know that I'm also a big fan of the Topaz Labs Gigapixel AI. So it's Topaz Labs Gigapixel. This is a tool that is sort of a desktop UI that also has a bunch of super resolution options within it. And let me just see if I can pull it up here real quick, show you what that looks like. So this is a company and they train their own models. So one of the reasons I like this one is they are constantly updating and iterating on their own models. I tend to find this is a better overall result for most of my images. So if I just go in and let me grab one of these images here. Let me just save out this image real quick. All right, well, we're going to get 2048 by 2048, make it really big. Okay, so this is going to be kind of annoying. We'll see how long this takes. It's a little dark, so I apologize, but we'll sort of see how quickly this downloads. The nice thing about this is they have a bunch of models, and the models are not just like random names; they have a different purpose, right? So see, the first one is standard, the next one is lines. So if you have an architectural image with a lot of heavy, strong lines, super resolution models tend to actually turn those into kind of waviness. So there's a lines model that will try to keep those hard edges. There's an art and CG model, which tends to be a little bit more artistic and keep a little bit more of a softness and blur to it. Then there are two low resolution models. So very compressed would be like if there's a lot of JPEG artifacting, you can actually, in this model, kind of remove a lot of that artifacting. And then low res is if it's a very small low res image, it changes how it sort of affects these things. So it's going to take forever to download. Sorry about that. But I just want to show you quickly, I think this model is really cool because of these options. And I do think as you'll see here, they have updated this model and I have to download it. It's a little annoying. I feel like every day I open it, I have a new model to download, but that means they're retraining these models and actually making them newly available. So I actually think Topaz Labs is a really cool tool. The downside is that I think it's $100 for the application. Well, that ends up being it's about $100 a year. They give you a year worth of updates and software updates for that purchase. So you pay $100 and then basically for the year you get updates. I think after that, you can sort of use it without updates, but they'll bug you a lot and tell you your stuff's out of date and that sort of thing. So if you're going to do a lot of this work, I tend to do a lot of this work. So I use Topaz Labs a couple times a week, if not every day. So in that case, the $100 is actually worth it for me. For those, maybe costs are an issue, or you just want to quickly get a simple up-res image and you actually find you like real ESR GAN or SwinIR, in which case you don't need to purchase these tools. Topaz Labs actually makes a bunch of different machine learning tools for photographers and video people. And usually they probably just stopped their like Cyber Monday sale or whatever. You can usually get it, if you keep an eye out on Topaz Labs, they'll usually drop the price to $75 like every couple months as sale. So you don't need to buy the $100 immediately. They also have bundles for all their other tools, so you could look at that too. I used to get discounts when I shared a referral code. They took away the referral code, so I'm just telling you I like the tool. It's not I'm making money off of it, but I do actually find it like it is one of the better AI upscalers in my opinion. So again, check it out if you want to. It's also got a nicer UI. There's a lot of other little features you can do with it. You can play with noise and blur and add some other things like face recovery, other settings as well. So I actually tend to really like this model or this tool. I think it works great. Thanks for that. It's a little, you can tell these people are not Apple or Microsoft, right? They're building these tools with probably 1 or 2 devs. They got some rough edges, but I would say in general, I do really like their tools, and I find them to be more often than not better than the default open source models, which makes sense because those open source models are trained by researchers, and those researchers just pull images off the internet and train off that. Whereas a company like Topaz Labs actually goes to photographers, asks them for their data, trains the models on really nice photographs or really nice artwork, and the data set is probably just much cleaner. So you'll get good results using that. All right, that was my hour-long lecture on super resolution. Any questions about any of that? Well, kind of straightforward, kind of not. You just have to play around a lot with the settings. Cool, so let's do this. Let's take a little break. So we're gonna do like a 10-minute break, and then we'll come back and we'll just sort of catch up. I want to hear a little bit about what excited people from this class, maybe ideas you're looking to take further. Because part of it is like if you're really interested in, say, text to 3D, I just put together a brand new notebook that does text to 3D. Not well, but it works. So if you want stuff like that, I can share that with you. But yeah, I just want to hear what sort of excited people about this class and make sure that I'm providing all the resources available to you for those tools. So yeah, we'll just have a quick check-in and chat and talk about maybe next steps for people. So I just talked for another minute. So let's come back at 37 after. So we'll come back in 10 minutes. Sound good? All right, cool. See you in 10 minutes.